Okay guys, today we are going to continue our solving trigonometry part 3. We are now number 20. Find the radius vector of the point coordinate or the coordinate from the terminal side of the angle. So the radius vector, this is the hypotenuse of the angle of a triangle. Now, our solution, first we're going to determine the given, the x, which is the abscissa is 4, and the y, which is the ordinate is 8, and the radius vector is not given. So this is why we're going to compute now the radius vector. Our formula, radius vector squared equals x squared plus y squared. So x is 4 squared plus y, substitute, we have now 8 squared. Then extract the exponent. 4 times 4 equals 16 plus 8 times 8 equals 64. Then we're going to add, we have r squared equals 80. Then we're going to solve for the square root of both sides. We have now r equals the square root of 80, and we're going to find the factor of this, which is one of the factors, the greatest perfect square. We have now 16.5, or 16 times 5 equals 80, and the square root of 16 is equals to 4, is square root of 5. This number is not a perfect square, that's why just only copy square root of 5. Next, number 21. Find the radius vector of the point -5, -4, or the coordinate from the terminal side of the angle. So our solution, first determine the given. The given, we have the x, -5, and our y is -4, and the radius vector is not given, so we're going to compute. Again, we use the formula r squared equals x squared plus y squared. R is the radius vector, or the other name for this is the hypotenuse. It's equals to, substitute for the value of x, we have -5 and squared plus the value of y, which is -4, substitute and squared. Then extract the exponent. -5 times -5 equals +25, plus -4 times -4 equals +16. And we're going to add, we have r squared equals 41. Then we're going to compute for the square root of both sides. We have now r equals the square root of 41, and the square root of 41, the radius vector now is 6.4. So this will be our final answer. Next, number 22. Find the 6 trigonometric functions of this triangle. This time, the x-axis and y-axis is not given. It's purely triangle. So our basis for computation is the given theta, which is the angle, acute angle. Now, for our solution now is given, we have to determine the given. We have to know the opposite. The opposite of this angle is 7, and adjacent of this angle is 13, and the hypotenuse is 15. Upon knowing this given, so we can find out the 6 trigonometric functions. The 6 trigonometric functions, we have sine, cos, tangent, cosecant, secant, and cotangent. Now, the sine theta, we have our formula is opposite over hypotenuse. So that's why our sine theta is, the opposite is 7 and the hypotenuse is 15. So this will be our sine. And the cos theta, we have the formula adjacent over the hypotenuse. So that's why cos theta, we have 13 and 15. And for tangent theta, we have the opposite and the adjacent. So that's why our tangent now is 7 and 13. Here, 7, 13, or 7, 13. So that's why 7 over 13. And upon knowing the sine, cos theta, and tangent theta, so the reverse of cosecant, so the reverse of sine theta rather, is the cosecant. So the reverse of this number is 15 and 7. And for the cos theta, the reverse is 15 and 13. That will be the secant theta. For the cotangent theta, you have to do is the reverse of tangent theta. Theta is the reverse of 7, 13 is 13 over 7. So that will be our final answer. Okay, next, number 23. Find the 6 trigonometric functions of the given triangle. This time, our guide for the computation is the angle theta given here. So the opposite of this angle is 20, and the hypotenuse is 23, and the adjacent is 15. So our solution now, first determine the given. What is the opposite? The opposite of this angle, this theta, is 20, and the adjacent is 15, and the hypotenuse is 23. Upon knowing this opposite and adjacent number, hypotenuse, so we can write now the sine theta, cos theta, and tangent theta. And the sine theta, our formula is opposite over hypotenuse. That's why we have 20 over 23. And our cos tangent, rather cos theta, is the adjacent over the hypotenuse. That's why we have 15 over 23. And for the tangent theta, we have the opposite and the adjacent. So the opposite and the adjacent. So that's why we have 20 over 15. And the reverse of this, the cosecant theta, will be the reverse of sine theta, is 23 over 20. We are going to reverse this number. And the secant theta, cos theta, 15 over 23. The reverse of this is 23 over 15 is the secant theta. For cotangent theta, the reverse of the tangent theta, 20 over 15, the reverse is 15 over 20. 20, this will be our cotangent. So this is our final answer for the 6 trigonometric function. Next, number 24, find the 6 trigonometric functions and the given triangles. The angle theta is here, so this will be our guide for finding the 6 trigonometric functions. So our solution now is find first the given, the opposite. The opposite of this angle is 35, and the adjacent is here, 17, and the hypotenuse is 37. And upon knowing this opposite and adjacent hypotenuse number, we're going to write the sine theta, cos theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Then our formula for finding the sine theta is the opposite and the hypotenuse. So that's why we have 35 and 37. For the cos theta, we have the adjacent 17 and the hypotenuse. So we have 17 and 37. And for the tangent theta, is we have the opposite and adjacent. So we have 35 and 17. Since we know this sine, cos, and tangent theta, so the cosecant is the reverse of sine theta. We have 37 and 35. And for the secant theta, to find this number, so the reverse of cos theta, we have 17 and 37, and the reverse is 37 and 17. And for the cotangent theta, the reverse of tangent theta is 17 and 35. So that's how to get the 6 trigonometric functions. Okay, next, number 25. Find the cofunction of sine 44 degrees. So our solution, copy first the given sine 45 degrees, and our formula, the cofunction of sine is cos, and 90 degrees minus the angle. This theta is called the angle. Now, cos 90 minus the sine 44, so we have 90 minus 44 degrees, so we have now cos 46 degrees. You just only copy the cos, and the difference of this will be our final answer, the cofunction. Cofunction now is cos 46 degrees. Okay, next, number 26. Find the cofunction of cos 60 degrees. So our solution, first copy the given cos 60 degrees, And the co-functions of cos is sine, and the formula is 90 degrees minus the angle, the theta, which is the given. And the sine now is 90 minus the given angle, which is 60 degrees. Then minus 90 degrees minus 60 degrees. So we have 30 degrees. So our final answer copy the sine. So this will be sine 30 degrees, our final answer for the confunction of cos 60 degrees.